All right, hello. Okay, this is going to be a lecture, kind of an introduction lecture to iterations, or otherwise known as loops. And I'll go and put right here in this main file, particularly iterations in Python. I'm actually going to do this in a few ways. I'm actually first going to do it with functions because functions and conditionals, because I know you've seen this before, or at least you've seen functions and you've seen conditionals before. Loops are going to be kind of new to us, or iterations, you might call them. Also, let you know it's technically a process called recursion. Then after that, I'm going to show you what proper iterations exist in Python. Actually, I'm just going to show you one of them, the for loop. So it's going to serve this iterations. Okay. So let's go and begin with defining what an iteration is. Definition is a structure that will repeat a segment of code. That's about it, actually. Could be a set number of times, or could have just very different different parameter attached to it. So far, we have looked at functions and conditionals and input, and just working with those three things. And we've already seen that you can do quite a lot. If you remember the Strisk lecture, you saw that we actually did quite a few things in that game, even if we never actually saw it to its completion. And we did it just simply with these functions, parameters, and conditions. So right here, I'm making something that works like this. If x is 0, then stop repeating. In recursion, we call this a base case, because it's the case where we want to stop doing whatever it is we're doing. In that case, we'll just say return. Oops. All right. However, actually, yeah, that'll be fine. However, otherwise, what I want to do is perhaps I just want to print out x, and I want to say currently on x. And that would just print out, whatever number we gave x. If I'm calling it repeats 10, you'll notice, and then if I run it, you'll notice it just prints out currently on 10. That's all, because I haven't told it to do anything. I haven't given it any condition where x would actually be 0 or 9 or anything other than 10. But here I'm going to actually do that. I'm going to say x equals x minus 1. I'm going to do what's called decrementing. That's where we decrease it by 1. Not too difficult so far. Still doesn't really change anything. But then, if I say, okay, call repeat again with x. Well, now, what's going to happen is I'm going to give it a 10. So x is now 10. We go through these if statements, and we find that no. We're going to go to else. We print out that we're currently on 10. And then we subtract 1 from 10, making x be 9 instead, and then call repeat again, this time with 9. Well, that means that now our function is going to be repeated with 9. Now it's going to print out currently on 9 and go down to 8. And it'll keep going until it gets to 0. And with that, you notice that we now have the same action repeated 10 times. That is the idea of an iteration. So this is actually, honestly, typically in classes, this is considered to be the more complex way of doing it. of doing a repetition. It's just I'm actually not sure of what other ways to present iteration structures to you. I've usually found that my students, some of them do just fine with it, but then others seem to continue having some trouble with iterations. So I figure maybe we can see it in this way first, in a way that you're familiar with. This way is actually extremely similar to the go-to statements. I think so anyway, that were back in assembly. But anyways. So that right there is the idea of an iteration. Perform the same task multiple times. And notice, if I want to get 100 lines of print, I can just change it to 100. And now, with such a small change, I've gotten so much more output. Now we can go ahead and actually make this a little more useful if we're like saying currently on, the square of x is x squared. Two multiplication signs makes exponents. And that could at least be something a little more useful to us. Maybe you need to get all these squares, I don't know. But notice, then to change it, I just change this number. Well, this is a very popular kind of structure. And this is a very popular operation. Well, very popular, what should I say? Very popular thing to do. So most languages did come out with these things called loops. Here's one that I'm actually going to show you here, the for loop. So for involves making some new variable that's going to go in some range. Range is usually going to be, for our purposes, just counting up, perhaps from 0 to 100, perhaps up to 100. We're going to do it like that. And we'll say, okay, print, and we'll do basically the same thing. Now notice, this is going to do almost the exact opposite of this code, because this one is going to go the other way. Oops. Oh, right. Because this one's going to go the other way. There's also one other change, is that it's instead going to be 0 to 100. So I could change it to 1 to 101. So that way it will go from 1 all the way to 100. Now I know that was kind of a jump, but here's what's happening. What it does is it makes a new variable and sets it equal to the first number in our range. Then it executes whatever this is down here. Then it goes ahead and it increments num. Increment is the opposite of decrement. Incrementing is to add 1 to it. So we add 1 to num, making num 2. So then it executes this stuff. And it keeps going so long as it is less than this number. The loop continues so long as parameter 1 is smaller than parameter 2. So long as 1 is less than 101. And I should probably say less than rather than smaller than. And so again, we have this very similar concept that we can change what number we have there and dramatically change what code is output. So that is actually the for loop on its own, just how it works. Its uses range through various things. Since we are moving into arrays as well, you can also use it with arrays. For instance, if I had an array called R and gave it remember we use append for this. We can also do it up here, but I just want you to remember the append function. So if I were to append a bunch of numbers onto our array, then I actually could go ahead and use that for loop to print out all of the numbers in an array. And oh yeah, we're gonna have to wait for that thing to finish. But yeah, as it's finishing, so that's going to, instead of going through a certain range, the second one here is going to go through each element in the array and print it out. And it prints it out just because that's what's down here. If we were to say, I don't know, have some kind of sum, and this is actually not an uncommon problem in computer science. If I want to add something, you know what, I'm going to go ahead and knock it down to like 3. Just so that way we don't have to wait for a couple times. It'll add up all these numbers, getting 492. So that is the for loop, and we've only gone about 11 minutes in, but I think that's probably enough right there. Just that one, and this one. And that's about it. Okay. Thanks for watching.